Hey guys, Happy New Year to you. We're going to start this new year off with another Minimoog restoration. And this also belongs to William, the same William I just redid the Minimoog for. So this is your Minimoog William that we're going to go through. And basically I've already started a little bit of it. I've pulled the back panel off, just doing a wellness check, kind of doing some diagnostics. See what we got to work with, what's been done to it already. And we definitely got some work to do for it, but it's not one of the worst ones I've ever seen. It does actually play decently, so we're going to start there. But it's either a very early 73 or a very late 72. It's missing the stickers, so we don't have any of the stickers in here. This would have had the white stickers, being a 73 or 72, but it's serial number 2181. So it's a fairly early Minimoog. It's already had the buffer board installed. Somebody's installed the buffer board in this one by those two screws. But yeah, we're missing the sticker, so we don't have an exact date. But I'm going to say it's going to be very early 73 to very late 72, based on the design. We have the embossed leather texture front panel, but it's got the metal backed panel like I always bring up. And we got the smooth white wheels. Of course, they need to be cleaned up, which also happen. But the cabinet is also the walnut cabinet, so it's actually got the better wood, so to speak, than the poplar cabinets we see later on in 73 into 74. But overall, it's not a bad looking unit. All the keys look pretty decent. They're out of alignment. It has been rebushinged, I can tell, but the keys will definitely be doing, just doing a wellness inspection there as well. See how the bushings look, and also do alignment, because the alignment is out. I can tell just by where the key's set that the alignment's not exactly where it needs to be. The big thing that you're probably already hearing is the transformer. It's loose, as you can see, and the plating is actually loose, the shielding. So I can actually grab it and move those. So we'll be tightening up all that in the process of the restoration. In order to tighten these up though, because it is an early Minimoog, I've got to pull the interface panel to access the screws, so I can actually get the screw heads to tighten this up. As mentioned, these early Minimoogs actually have screws with Phillips head screw heads behind here. They're countersink into the metal, whereas later they actually machined in the actual threads, so you don't have to worry about them turning with you. They're machined into the aluminum. These are not, so it makes it a little bit more tricky for servicing for stuff like that. It has had some recapping done, but it's the wrong setup for this. I'm going to actually be reversing this. You can also hear 60 hertz hum in the actual audio, which will be addressed when I replace the rectifier diodes, because you can see they're pretty old. And then we'll also be updating the scalp set here to help with the 60 hertz hum that we've got going on there. We got Minimoog filter board. I already know that. They should have all Minimoog circuit boards in it, based off the date, or based off the serial number. I hadn't pulled the board, so I don't know for sure, but this board here is correct, because we got the blue trimmer that was added basically to the version 1 filter board here. So we'll be addressing that. We got the version 2 oscillators here, and so that looks pretty good. It looks like it's mostly original. We have some caps that have been replaced. You can see how these are just sticking off the board, which are stretched legs, once again, radial caps, which I don't like to see that. So we'll be replacing those with axial style caps. But yeah, overall it's not a bad Minimoog. Like I say, it's got some modifications we will be taking out as requested by William, such as these jacks here, which are actually these jacks, but they were rewired here so they would work with a normal size 1/4 inch, because these are not 1/4 inch. So that was done, but we're going to reverse that back, get it set up back like it was originally, and take care of that. But overall, it's a good looking Minimoog. The wood needs conditioning. We're not going to refinish it, of course, but we are going to just kind of give it a good cleaning and conditioning. It has William's band here. Source. What's the name of his band, for those that are curious. And but we'll give everything just a good deep cleaning and servicing and go through the boards. The oscillators are wavering really bad, which is probably all caused by this power. You can kind of hear the So oscillators just kind of, they're wavering a whole lot. They kind of track, they don't track real well. Let me actually tune this thing up real quick. Oscillator 2 seems to be the worst. They don't want to hold tuning. As you can hear. But it does work. When I first got this thing in here though, everything was bottomed out trim wise, so the oscillators were way out. They're like B sharp when you're hitting the A note. And then of course the filter, it started self-oscillating at like, it would start self-oscillating at about 6 on your emphasis, which is only supposed to start self-oscillating about 7.5. So it should start oscillating right there. So I had to calibrate that, which it calibrated just fine. I don't see anything acting crazy there. But like I said, it just needs, you know, the power I think is the biggest issue with this one, because I can hear all that noise and the 60 hertz, and of course that transformer being extremely noisy. But even when I quieten that transformer down, you can still hear the 60 hertz in the audio. We got some wiring we're going to address. It's very unsafe looking. It looks like somebody's kind of done some work in this one, but you can see how that wire is all mangled up, really poorly soldered in there. Power cord's been replaced. It's got a flat cable on it, which this would have had a round wire by this time. The early Minimoogs, like the 72s and 71s, they actually had just a lamp cord, which was just a 2-wire cord without the earth ground. This one has the earth ground, but it's just a flat wire. So I may be putting a different cord on it, because also this one, made for a round cord, it doesn't really secure, so you can see I can turn it in here pretty easy. This thing's not completely biting in to where it needs to go, so it's real loose. So we'll probably be putting a different power cord on it, the proper power cord for this era. And just kind of clean some things up. Somebody's replaced the pilot light in there. You can see by the shrink tubing, which they did use shrink tubing, which is really nice. Sometimes I just see them just in there kind of like halfway put with black tape, which is kind of scary, especially when you talk about 120 volts right there. But we're going to just give it a good servicing, a good restore, and make sure this thing's going to be great for him. But with that said, let's get started. Now the board's all removed, and just going to take a quick look inside here, and I already see some problems we got. The buffer board was installed backwards. It looks like somebody used duct tape to kind of do something. I guess they're afraid it's going to touch something. But basically it's kind of jankily put in here, so we're going to redo that for sure, clean that up real good. Also the backboard's only held in with 1 screw each, because we are missing the standoffs that go on this thing. You can see that we've got one standoff here, of course it's loose, but we're missing the other standoff right there. So you can see it's still got the screw behind the interface, but we're missing the standoff there. And same thing on the power supply. We got one standoff here, but we're missing the standoff there. So we'll be addressing that as well in the process. We have some modifications. This is a wire that's added as part of this jacks that was installed to make all that work. So we'll be cleaning all that up, getting it set back up to factory there. The boards are actually Minimoog boards, so they are original boards to this unit. Somebody's definitely done some work to the modulation mix. You can see we got some resistors added there. Looks like 120K on the front, and then we got a 330 on the back, based off the color codes there. So we'll be addressing that, see what's going on there, see if there's something other besides that. We've also had a repair, it looks like. They used some wire to tighten those up to try to get a better thermal compensation there on those transistors for TS97s, I believe there. We'll see what's going on there exactly. And but it has been recapped there. You can see this has new caps in the board, except for right there. You can see once again we got those that has the legs stretched way out. And we're going to get rid of those and put the right style caps in there. Instead of the radials, we'll put axials. Oscillator board is still very much original. It looks like somebody's replaced these at some point. I can see where they've actually soldered the leg. Needed to make the actual body of this thing hot. You can see right there, it's just soldered together on that one as well. Not bad though, it's just kind of how you do these particular parts. But those might actually be factory though. Looking at the solder on the back, they look like they've had rework there. But anyways, we'll address all that as well and give that a good servicing. But anyways, that's kind of what we got inside this thing. And now we're going to flip it up, pull the keyboard, see how the keyboard looks, and we'll kind of go from there. And for those that are more curious about what they're looking at here, be sure to check out a book by my friend Joe Silva, the Minimoog book. This actually covers a lot of the history of the Minimoog, as well as what's inside the Minimoog, and even famous users of the Minimoog and how they approach the Minimoog. So really good read if you're really interested in the Minimoog stuff here. So before we moved on, I decided to go in and remove the modifications that were in here. This was added jacks for the switch for the glide and attack. They went to regular size 1/4 inch. And so I got all that removed. As you can see, all this stuff here is out of there. Got everything wired back like it needs to be there. And I went and dropped the buffer board. You can see it's just kind of installed quick and dirty. Whoever did this just got it in there to make it work, really. So we're going to be taking it back out, rerouting this wire to make it look really neat. It's also installed backwards. So it actually is mounted in there like that. It's supposed to go this way in there, the correct way. So we're going to get all that cleaned up, run the harness nice and neat, and make that look a lot better as well. But I think at this point we're ready to drop the bottom chassis, and we're going to get the keyboard removed and inspect it real good. And we can also start kind of conditioning the wood as well, because it's really, really dry. So the conditioning is really going to make this thing pop and look really good. But anyways, let's continue on. So now look underneath the keyboard here, and you can see this plug here's been replaced. That would have been a Sense Jones originally. It's been replaced with a Molex, which is okay. That's fine. But we have got something that's going to be a deep subject on this particular unit. As you can see, the keyboard, the contact bar is actually broke. You can see all these pieces that are falling out of here. They're just all brittle. These things are just breaking off, as you can see. So what that means is that our keyboard circuit board is not held in place. It's just floating in there. So you'll never get alignment right. Some of these contacts have also had to be adjusted. You can see how the springs are sticking out of them. So we've got our work cut out for us on this one, because I got to pull all the keyboard apart to fix this. So that's what we got going on. But you can kind of see, I'll show you an example. There's one of them. Let's see if it'll break off. Yep, snaps right off there. It's just rotten old rubber there. So this keyboard circuit's not held in by hardly anything anymore. So we're going to pull the keyboard, and it looks like I'm going to have to find some of these new standoffs for the keyboard and get that fixed. But that's where we are next. That's the big part of this thing. Circuit boards, that kind of stuff's pretty quick, but that's a pretty major undertaking here. And with the keyboard pulled, I did find some dates that let us know it is a 73 Minimoog. So this is January 3rd, 1973 on the keyboard. That's the stamp of the actual print read keyboard date. But if we also look inside the chassis now with the keyboard out, somebody's actually written a date here. So we have, it looks like 2/12/73. So February 13th, I'm sorry, February 12th, 1973 is the date inside this thing. So it's like it's a February memory moog based off our serial number and what I'm seeing as far as date codes inside the actual chassis. But anyways, just thought that was kind of cool. It's actually overall pretty clean. I mean, we're going to vacuum it up, clean up the chassis real good, and we're going to condition all this wood so it's really dry right now, so that'll really make this thing come alive. But we'll also be pulling this interface panel to access those screws, to replace the standoffs, to tighten up the transformer. So we're also going to be pulling everything apart. So we got that going on. But I think first things first, I'm going to focus on this keyboard and get this all rebuilt with new standoffs for the actual circuit board. Because right now, I mean, there is, as you can see outside the chassis, you can just see how much motion there is. That's why the key contacts, this thing was kind of jittery when you hit a note, and that's the issue. This whole circuit board is moving front and backwards. So there's nothing there to really hold it. It's kind of odd to it. There's usually a little plastic piece that goes on this era Minimoog that actually kind of holds this board in position. And I don't see those on this one. So somebody's either already been in this and taken those out, or maybe this just didn't have them. I don't know, but I always see them in 72, 73 Minimoogs. So I've got our contact board removed completely now from the keyboard assembly, although it didn't take very much because all those things, all the mounts were rotten. But what I've done here is I've actually just went to the keyboard and just kind of inspected the springs, the contact springs, the actuators, which is actually how this thing triggers notes. And I had one in particular that was just really bad, and we can see it right here. I've actually already desoldered it, and it looks like it broke at one point and then it was pulled back through. And what happens is you can see how this thing sets. The front sets lower than the back, and I think this might have been done also for the circuit board being loose like it was. It probably had a lot of contact issues on this last note. And so when I put this thing back in there and mount it, what's going to happen, it's going to push up on this guy here because it's lower, and we're going to always have this back spring that's going to do this weird dance motion, as you can see. And it's already been damaged previously. So I'm going to be removing these springs here and installing new contact springs. So these are our new ones right over here, and I'll be putting those in, resoldering this in, get the height set right, and then should work like the other keys. And of course then there's just the idea of alignment and contact travel, key travel, all that kind of stuff I do during the restoration. I actually align everything. So we'll get this thing set right. But I just want to show you that real quick. And it's quite a job, especially if you've still got those rubber pieces that are good that hold this board in. It's quite a fight to get this thing out of there and then get it back in. You're just about to tear the keyboard apart, because if you want to reuse those little rubber pieces if they're still good, you have to lube them up real good. You have to put them back in the keyboard, and then you have to set this board back down on them. So it's quite a task, and also not stressing out your actual bus bars. Make sure you don't bend those too much. This one's got a little curve in it. It's not real bad, and it should straighten out once we mount this board correctly. I don't think we'll have any problems there. But anyways, just want to show you that real quick. Now to remove these springs, I will show you this right quick for those that are interested. You just kind of see how they set in this actuator. And so you desolder them, you have to pull them completely out of the circuit board. And basically you just kind of twist them. You kind of feel twist in there, and they'll twist out usually. We'll see if this one might be stuck. Of course we're not reusing these springs anyway, so I'm not real worried about these particular ones. Basically just get where it rotates in there, like so. It's starting to move. I don't know if you can see on camera or not. Let's see, maybe you can, maybe I can get it to focus. I don't know if I can or not. I can get that to focus. Anyways, I'm twisting it toward, like you're tightening up the spring, and it basically I'm just pulling it out of here, and you can kind of see it coming out. So as I twist it, there it is. So I actually twist it outside that. You can see where it's real clean there. You know, see the kink in it. That's why I'm replacing that one. So throw that down there, and then this one here has been stretched. As you can see on the front side, there's actually springs sticking out. There's not very much in this actuator, so more than likely when it starts pulling on this, it's going to actually pull it outside this actuator, and we'll have other problems. So we'll twist that one. You can actually see that and twist out. Try to get it through there if I can, like so. And then to install the new springs is basically the same thing. Key thing is make sure you get it in the right hole. So because you actually got these actuators are made for different style Pratt Reed keyboard designs, like if it's going into organ or whatever. So it looks like we got to use the back one here. Look at the spring. There's a top and bottom of these springs. You can see that little area that's actually open. That goes toward the circuit board. So what we're going to do is we're going to take our actuator, make sure our actuator, this is actually facing up. You can kind of see right here we got a gap. So this is actually on the top side of this actuator. That's going to be the top, like that right there. So what we'll do is we'll take it, put this in the back, and just once again just kind of twist it as you put some pressure on it and feed it up inside that hole there. And you can kind of feel it, and you'll see it also. You can, because they're clear. And there we go. There's one new spring in there. We'll do the same thing to the front. Get this resoldered in and get this remounted. And there's a new contact springs installed there, as you can see. And they work just like so. So when you pull the actuator, it's going to pull against those bus bars. That's how that works. I was looking over the keyboard one last time, though. I do have 2 more contacts I'm going to replace. This one down here, if you look in there, you can see it's definitely, whoops, it's definitely messed up there. Let me see if I can get that to focus. Come on. I have to manually focus it. Let me see if I can. There we go. Yeah, you can kind of see right there how that spring is actually damaged at the back. That's your gate, or your V-trig. That's your CV line in the front. And like I mentioned, you always want your front ones to hit before the back, because otherwise you'll get that real squirrely note problem that these things are known for. But yeah, that front one right there, you can see it's actually damaged here. That one's damaged at the back. So I may can reuse the front spring on this one. I don't think it'll be a problem, but and the back spring looks okay. It's just that front one there and that back one there we got to replace. But just doing a good inspection. That's why inspection is really important when you have this thing all apart, because you can catch these things while you've got this board out. So anyway, it's going to replace those, and then we'll get this board remounted. So the contact board all fixed up now. I've now stripped the keyboard down, the actual assembly, and about to start cleaning this thing up. You can see just how crusty it is in there. Got the keycaps removed, and I'll wash those. And of course got our contact board all fixed up. Also polished the buses, so they're nice and clean now all the way down, as well as I replaced these last 2 troublesome contacts. If you look right here, you can kind of see that they're no longer all bent up. If I can get this thing to focus, there we go. See how great that one looks? It was the front one on that one. You can see how good all that looks. So that's all taken care of. I now have our keyboard assembly put back together, and I've decided to change the design a little bit of how this thing goes back together. This is something I've been fighting for years, and that's actually these little rubber pieces that we're talking about that broke off on this particular unit. And just quite frankly, I hate these things. I hate them with a passion, because they're really a pain to get back in there. They're a pain if you ever got to take this thing back apart. And also, it's getting very hard to find these things with the correct spacing. You can still find these on their own, but they don't have the right spacing between the bottom half and upper half. You need 3 millimeters, and this is anything that you find is going to be like 2 millimeters or 1 millimeter in that space. And so they don't get you the right gap you need to set your contact board. And that's a real problem, because if that's offset, if it's too low or too high, then it actually changes the whole angle of your contacts and how they pull against the actual bus bars. So having that gap between the keyboard and the contact board are very important. So what I found is I actually found some spacers, just some nylon spacers that are exactly what we needed as far as the spacing. And while I had this thing apart, I epoxied some nuts on the inside of the key bed, and I've now got it held in place with screws. Now the other benefit of using this design is I went with a smaller screw size than what the hole is in the board, for the reason that you can actually adjust this thing. And I'll bring this up because I've got original Minimoog keyboard here that I hadn't touched yet. And as I talked about earlier, we're missing those little blocks, which are these right here, which you can now see. The problem is with the keyboard is that this contact board, even when it's mounted with these rubber pads, sometimes they didn't exactly line up with where the holes need to be for the position of where the contacts need to be. And so they'd use these blocks to push in on this keyboard, this contact assembly, to push it forward so you had more travel toward the back of the actual contacts. So talk about a headache, just kind of a headache trying to get all that to line right. Well, now with this design, all you got to do is loosen the screws. To service this thing, you can actually take these all out. This whole board will just come off by removing screws. But also, because that's a smaller size screw, I can loosen all these up. I can actually move this board where I want it. And I can tighten it down once I get it where I want it, and then we're set. We've actually got all that frustration fixed. And it's well mounted, it's not going anywhere, and it's just fantastic. So once again, I epoxied a nut on the inside, used a spacer between the keyboard assembly and the contact board, and then what I did on the top is actually for these back screws, because you can see they're pretty close to circuitry, I used a nylon washer as an insulator, so we don't have to worry about those. And the only thing that I couldn't do, that I wanted to do, was use nylon locking nuts on the inside, but they're just a little too tall for my comfort. I was afraid there's going to be some interference with some measurements I did, especially if the alignment gets a little out. And so I ended up using just regular nuts, but I used a medium strength thread lock on all these screws. So they're locked in and they shouldn't go anywhere, but that's kind of what I've done to it. So really happy with how that turned out. I think it's going to be a lot easier to work on in the future if it ever has to be. And this is something I'm probably going to start doing to Minimoogs, where I have to fix contacts, because this is just such a hassle. And these things always break, and it's just a nightmare trying to get all that stuff put back together. So this solves all that headache. But anyways, next thing on my list, I got to wash the keycaps, get those cleaned up, and then do alignment on this keyboard, and the keyboard assembly will be complete. So a few things have happened off camera here. Got the keyboard put back in this thing after the rebuild. I've also conditioned the wood. The wood conditioning was going on while I was rebuilding the keyboard, letting it soak with some good conditioner on it. And basically, conditioner doesn't really hurt the finish. All it does is it's an oil that has a wax with it, and it basically lets the oil soak into the wood, keeps it from cracking, kind of rejuvenates the wood a bit, and just makes it look really good too. It makes the grain come back alive, so all the grain looks much better than it did when it arrived. It was kind of just a flat looking Minimoog on arrival, so that conditioner really helps with that. But also I've been working on the interface. So I've pulled the interface panel off. I've actually delaminated it. As you can see, it's now nice and dark. You can see all the colors. It doesn't have that white haze to it anymore. Looks really good. There's the finish on it. I'll set this down real gently here. But there's the actual laminate that I removed from it. So that's what we took off this thing. And you can just see how great that thing looks now. That's the original panel. So now I'm going to start cleaning the potentiometers, clean the interface panel up really good. And I'm also working on the transformer now. This is why I had to take the interface off anyways, because you can see, as I've mentioned in my other videos, this era Minimoog actually had screw heads in the front. But I will show you something interesting I found on this Minimoog, which is why I think the transformer was loose in the first place. So we're now looking around back here. I've already dropped the transformer, and something I found out is that Moog actually just stacked washers. I believe this is factory. I don't think this is something somebody did. But you can see that we have the screws in the front, which is why I removed the interface, and you can see they're just floating in here. They stacked washers. There's no real good way to get a compression on that to hold that tight. So I think that's what's wrong with it. Now this is a 73 Minimoog. Now mind you, it's an early 73, but I've got another 73 chassis, and this is what it should have from what I've gathered over the years of looking at these things. There's a block of aluminum that goes under the transformer, and that's actually what it mounts to. So I'm going to see if I can remove this piece of aluminum out of this chassis. This is a donor. This is the one that got crushed. This is one I took all the guts out of and put into a 74 chassis. I've still got this laying around, so we're going to use that for this aluminum piece to put behind that transformer, and that should help all the vibrations and weirdness that's going on with that. But we're also going to be cleaning up some wiring, as you can see I've already desoldered some stuff here, and somebody replaced the pilot light, so they just tacked it in there and put shrink tubing. So we're going to clean all this up really good while I'm in here. Put a new power cord on it. I've already cut all the power cord wiring, so we're going to get rid of this power cord, put a better power cord on it, and of course go through the whole everything else. We're going to take apart the pots, flush, lube them, redo the rectifier filter setup here, and get everything like it needs to be here. But anyways, just thought that was interesting. Thought some of you guys might like to see what I found there with these stacked star locking washers. Never have seen that before. Alright, so I got that aluminum bar out of my donor chassis over here, and I'm going to install it in this one. But as you can see, it's actually threaded into the aluminum. That's part of your support. And so what I'm going to be doing is putting this back in there with some good heavy thread lock, so this thing does not come loose again. Especially now since we got this thick aluminum, we shouldn't have the issue we had with these stacked washer deal that we had going on. That's crazy. But I think it's factory, and the reason I think it's factory is because the way the harness was ran. This wire here was ran underneath the transformer, as well as this power cord I've actually cut. I've sniffed it. We're going to be replacing that anyways, because you can see that wire's in pretty bad shape. So we're going to replace that in the process, but it was actually running under the transformer. So I think this was actually factory the way it was set up, but we're changing that. We're going to put this in there. I'm going to clean this up. You can see a little bit of residue from the old transformer that was in that unit. I now have our transformer remounted here. It's nice and tight. It isn't going anywhere. Use some Loctite, a thread lock on everything there, as well as some lock washers for the transformer itself, like they're supposed to be used. So got that. Also put a new power cord in here. Got that wired in. I'm going to install it into the harness when I get to the pot cleaning and everything. We'll actually integrate all this into the harness like it would have been a factory. But all new wiring all the way down to the fuse. So this wire here was kind of rotten, so that's now replaced with a new piece of wire all the way to our switch. Got some of our switch cleaned up down here, as well as our transformer windings right there. It was all really nasty. Of course I didn't clean the flux or nothing. I got this wire here that'll be coming out as well. It's just stuck in there just for reference. That's where the pilot light was replaced and soldered in. But everything still needs a good cleaning. I mean, I hadn't got that deep yet, but mostly just getting that transformer like it needs to be right now. I now have this thing all back together here as far as the interface goes, and you can see it's looking really sharp. I've rebuilt the LHC panel here. I delaminated it as well, and ended up having to rewire most of this because of the modifications that were added. I set it back up to factory, got rid of all that stuff, and also did the dead zone mod. So now it's got the dead zone mod for the pitch wheel, so you got a true dead center when you're in the detent, which really makes the wheel much more usable. And just looks really good. It's just turning into a really nice Minimoog here. But what I'm doing today is actually I'm starting on the circuitry, and I'll come back around here. My camera's plugged in, so bear with me. So now I'm working on the inside of this thing on the circuit boards, just kind of going through them, doing some good maintenance to them and some restoration work. And one thing I'm working on currently is this actual modification. We have these resistors that were just stuck into the modulation mix bus or amplifier circuit, and so what I've been doing is reverse engineering that and figuring out what they were actually doing here. So I've actually redrawn the circuit, and I've drawn it with the modifications just to kind of show you what I found here. So originally what happened is the Q17 base would have been connected to ground originally. So it actually would have been up here. Now, excuse my notes, this is just for my reference, but I've got a few markings. So you can see like new trace, I've got drawn with the little marks here, and then the old trace is the dotted one. And so if you look here, you can see the new tracing here going from negative 10 volts, 120K, which we see tacked in there, and then up here to the base of Q17, it goes through this 330 ohm, back over here to ground, where originally this Q17 base just went straight to ground, is how that worked. I've done a lot of measurements, and we only have 25 millivolts on Q17 base. So what I'm thinking is that this was actually added as part of some kind of testing. Like maybe this unit had an issue with ground at some point, and so instead of making it have a ground reference, they made it have a 0 volt reference using that voltage divider to get like, it's only got like 25 millivolts, so very, very little voltage there. But with that added, I've gone back and forth between a board that's not modified and this board. As you can see here, I've got the board in my hand, and you can see that's not modified. and I've gone back and forth, and I don't see any difference in the readings between what I've got here and what I've got there. We still got the 2.48 peak-to-peak voltage on the output of this amplifier, so it really doesn't have any benefit to gain at all. So like I say, the only thing I can imagine is maybe at some point in this Minimoog's life it had a ground fault. Maybe it wasn't getting a good ground to this, and it would have some modulation problems. But of course we're going to be tightening up all the flags. As you can see, this board's pretty loose in there. So we tighten up all the flags and everything. But as far as that goes, I don't see any reason to keep this. So I'm going to pull this back out. I'm going to set it up factory, do a lot of testing that way, make sure it does exactly what we want it to do. And I can address it from there and actually do the repair it needs if it needs any repair in that circuitry. So I've ran into a problem with this Minimoog that's sort of uncommon. I've seen this in the past, but not quite the same failure trend that I've got with this one. And that is that I got all the boards kind of in it, and I was, messing with it, doing calibrations, testing things out, and I realized I could actually move the chassis, and I couldn't get this thing to hold frequency. It would actually drift out of frequency. I also had a weird key issue that I've been trying to track down. I thought maybe it was a contour envelope issue. Sometimes I see the envelope generators have issues with certain transistors during certain eras. But this one didn't have those transistors in it, but you can still have age problems just because, if it's a heavily used Minimoog. So I've been trying to rule out problems like that, and I couldn't find anything right off my hand. But as soon as I started moving this chassis and started getting that frequency shift, it all kind of interconnected to what I was fighting. And so what it does, first of all, I'll show you the symptom that was really driving me crazy, and that is this right here. If I hit a key and just let off the key very easily, and what's very odd about that shift is we're looking at oscillator 3 right now. Oscillator 1 and 2 do not have that on it. So it actually caused a detuning effect in oscillator 3. And I've tightened up all the flag connectors as part of the restoration, so it's not a flag connector problem, but it's a harness problem. We've got a sensing issue on our negative 10 volt power supply rail, and it's actually this gray wire down here, and I'll show you what it does. So I can wiggle just this harness on its own, as you can see, and when I bend this wire just right, we no longer have that contact issue. So that actually fixes that problem. It's also not a flag problem because I can actually wiggle this board. So it's not a actual flag connector problem, it's a harness problem. So glad I found that, because that was one of those moments where you do run into stuff where you, even as a technician, you work on this stuff all the time, and you get little weird niches like that with certain units, and you can spend hours trying to figure out what's causing a problem. And so I trace it down. It's just the wire in the harness. I'm going to take that wire out completely, replace that wire as a whole, and we'll get that fixed, because it's probably either a break in that wire and maybe it's still touching, but it's got some resistance, and as I move that wire, it's just changing the sensing between the 10 volt rail. That's what I believe is going on with that wire. Well, that's what it'd have to be, because it's a sensing wire. So I'm going to fix that. But something else I've added to this Minimoog off camera is actually I've modified this one with new jacks up here, and I've built a little circuit board you can see right here. I turned this light out so you can see a little bit better. But I've got a little circuit board right here, and what that is actually a 5 volt regulator with a comparator circuit. And it's the same thing I put into Williams Minimoog. And what it does is it actually gives you powered CV jacks, like you find on newer Moog instruments, where you can actually use non-powered expression pedals like the EP1, EP2. And it allows you to actually have powered jacks. So what you get is, we get something like this. I'll hit a key. As you can see, I was looking at the oscillator input. We've also got the filter. Now you'll hear a frequency shift because that's a ground reference jack. So when you pull that out, it makes and breaks a ground connection to keep things from floating. So it actually will still shift when you unplug that. But we'll go here and we'll shut this filter up a little bit. And now I've got it plugged into the filter. So we're doing filter sweeps with the pedal. We also got the loudness. Plug that in, and of course you don't have anything to there, as you can hear. But the benefit of having the comparator circuit is that actually we can still use it like a normal Minimoog. So if I take a TS jack, like this right here, our TS plug, and let's say that you want to use like a CP251 or a Moog sequencer or something of that sort, without the comparator, what would happen is you'd plug this in, it would short the 5 volts out to ground, and you'd burn up your regulator. So what the comparator does is it actually shuts off the voltage. So for example, we'll plug into the oscillator jack, and you can see that we lose our 5 volts. We still have our 5 volt regulator running. It's still working just like it did, because you can see we still have filter sweep. So we can go here, and you can see it's still working just fine. But if I unplug this jack here, you'll see that 5 volt recover. It turns that comparator back on. So now we got the comparator back on there. And so that's kind of how that works. It allows you to use non-powered expression pedals now with the vintage Minimoog. And just really nice. It's a really nice kind of cleanup from what you used to have to do with like the Moog 1120 pedal, where you had to put a battery in it. You had a 9 volt battery that would supply your CV voltage through the pedal, and these jacks weren't powered. You couldn't just plug an expression pedal in and make it work. But now with this Minimoog, you actually can. So that's something I modified there, and just making good progress, but I'm glad I found that wire. So next thing I'm going to do is replace that wire, hopefully take care of that problem, attempt calibration again, and we'll see how things go. So while I got the boards out, I did forget to show you the inside of all the work I've done here. So I've got all of our new harness installed here for our 120 volt lines. As you can see, I've got all that. I've actually put a new piece of insulator there across our fuse holder so we don't touch the 120 volts when we work inside this thing. But we'll go on down here, clean all the pots. You'll see little black marks on the back of the pots. I did that. As I go through these things, I actually physically open them up, flush them, clean them, inspect the carbon tracks, and then put them back together. They're sealed, so you have to actually open them up, as you guys have seen on my other videos. I got videos showing how to do that. I've got the buffer board all installed correctly now, so it's mounted like it's supposed to be. Rerouted all the harness there, cleaned it up. Might look a little bit neater than what it did anyways. And then we're going down, and there's our modifications. A little board we added, which looks great. And I went on to put my signature in this one anyways, even though we still got a problem. This thing's not going to leave till I'm happy with it anyways. But since I got the boards out, I can do that and then put the boards back in. And just has my signature for the restoration in it. But anyways, just want to show you that real quick. I've now replaced both sensing wires for the negative 10 volts. A gray one was one was having issues with, but I want to replace them both. And as you can see, I got them all nice and tucked back in there. And if we do this right here, got good tuning, no problem, as you can see. Now so we'll go back. Here's just one oscillator again. We have no key contact issue there. So we're doing fantastic. So that's what our problem was. And now everything's zip tied back together, and we're going to do a final test here, see how it works. We'll hit a note. I got all 3 oscillators on. They're real nice and uniform. That's great. No problems whatsoever in the harness. It's all fixed. So that was our issue. Now I will bring up too that it is normal to have a little bit of a offset in pitch when you let off a note. So this is about what you want to see normally. So a little bit of movement. So here we got just a little shift, but not very much at all. And that's about normal because you still have a mechanical and electronic interaction there between the contacts. But that's great. So this thing's fixed as far as that goes. So now I'm going to try calibration again and see how that goes. And I already kind of been a little rough with it, as you can see, and it's holding tuning. So I'm pretty sure we're not going to have any more harness problems out of this thing. And for those that might have saw the Minimoog in the background on the floor in pieces, I've been using this one to test boards and Williams to rule out harness problems, which we found is a harness problem. But this is that crushed Minimoog I put back together from another Minimoog. Beautiful instrument. It's a 73 Minimoog as well. October 14th, 1973. But I got more on this Minimoog. I'll put a link in the description for those that want to see the rebuild of this one. And I hadn't fully rebuilt it yet. As you can see, the boards have old caps and stuff in it. But I do have most of the chassis rebuilt. But I'll put a link in the description for those that want to see that video. Alright, one last shot here before I put the back cover on it. Just a good overlook of all the restoration work that's been done. There's no longer any 60 Hertz hum. Transformer's nice and tight. There's no vibrations. There's no 60 Hertz here or in the speaker. So it's sounding really good. Very happy with how this Minimoog's turned out, especially after I found that harness issue that we had. That solved a lot of the problems we had with this particular unit. But turned out really nice. Something I will show you that's kind of interesting. I cleaned this back panel up. I was looking on the inside of it, and we've actually got some information here of when this thing was serviced. So we got oscillator filter tuning, February 25th, 1975. Then we got oscillator filter tuning again, 6/11/76. Oscillator filter tuning again, October 24th. I think that's 77. And then we got modifications. That's a Moog part number there, 94-002. I have to look that up and see what that is. But that could be the buffer board or something like that. Modification DCM 13176. Then we got another one the same date, 94-002. And then we got another one the same date as well, the 93-115 upgrade. That's 13176 as well. So I had all those done. But anyways, we redid all that again because we got all that cleaned up really nice and put in there a little bit more professionally. But anyways, looks really good. Really happy with how it's turned out here. And also, I have installed the factory style spacers in the board. It had rubber grommets used. Got rid of those. It had some tape residue here. It's evidently there's some tape used to maybe try to isolate something at some point. So cleaned up all that residue that was on this thing. And just looks really good. The only thing I hadn't fixed yet is this little trim piece. I'm going to fix that. It's actually missing part of it, but this is actually a rare piece of it because this is a metal one. The later ones they become just a vinyl, like a silver vinyl. But this is actually the metal one like the early Minimoogs. So, just kind of neat there. But anyways, I'm going to put the back cover on it, let this thing heat soak, do another calibration. I've done a rough calibration at this point. It's doing fantastic. Calibrate the filter, of course. The problem is with this filter design, once you put the back cover on, you cannot calibrate it because of the CTS trimmer style that's in this board. Of course, in 74, they had changed this from a CTS trimmer to a rheostat. In fact, I think I've got a board over here I can show you. Let me strap up right quick. Use my ESD control stuff. Let me strap up over here and I get it off my table. And I've got an ESD table behind me here too. So this is a 76 board, and you can see it's got the rheostat. So that has the CTS trimmer. This one's got the rheostat. Of course, this board's been serviced by somebody else. That's not my work, but anyways, that's just an example of the rheostat versus the CTS trimmer. So I just thought that was kind of neat to show you there. Well, I've got that board. But anyways, don't put the back cover on. We'll continue on. This Minimoog is now complete, and as you can see, it looks fantastic. Sounds fantastic. It's had a 10-hour burn-in on it to make sure everything holds up. And of course, the last little details I've done to it is I put in some new hardware for the LHC. So these screws here were actually drywall screws when it arrived. So got those out of there, installed some nice hardware there. Clean interface panel, of course, as you guys have seen. All the pots have been cleaned, switches, etc. The wood is conditioned, not refinished. That throws a lot of people off, I think, because a refinish is actually where I sand these things out, and I'll either stain them or I'll put a natural color back on them, and then I'll actually urethane them. Usually on later Minimoogs, where the cabinets just became a lacquer finish poplar cabinet, which was, you know, kind of Moogs. I don't know why they did that to their high-end instrument. But this walnut, these earlier cabinets, they actually are kind of a raw wood just kind of with a rub-on stain, and so they tend to dry out. And so conditioning, as you can see, does wonders for these cabinets. It really makes these things look good. I delaminated the badges so they match the interface panel, so they're nice and dark as well. They don't have that white haze to them anymore. Of course, you guys saw the rebuild of the keyboard, etc. Went to the keyboard, redid all that. All the old components, these are the jacks that were installed as part of a modification I removed, and I plugged the holes with little plugs up there, so they're no longer there. These are original jacks associated with the CV control for like the loudness VCF oscillator. Had to replace these as part of the modification for the powered jacks for expression pedals. So that's why those are removed. These are all the old components that was part of the restoration and repairs, getting this thing to work like I need it to and be reliable. And also, here's the old key bushings. We want to put new key bushings in this thing while I had it apart as part of a request by William. So these are the old key bushings that were replaced, I think, roughly in 2016. They're still good. So I just bagged them up, and he can have those to go with him. He can use them in something else if he ever gets another instrument with 44 keys that needs key bushings. Those are still pretty decent. The old power cord's been replaced. Of course, you guys have seen that earlier. It's a new power cord. Cleaned up the back panel here, so got that all cleaned up. And of course, once again, just that wood conditioning made a huge difference to this cabinet. This was all kind of white color right here. It's just so dry. This whole cabinet was very, very dry on arrival. So the conditioner made a world of difference just to the cabinet alone. But cleaned everything up really good. And of course, William, this is your seal number here, 2181, as you can see. And we've came to the conclusion, this one was missing all the stickers, so I didn't have the date codes or the where it went through all the inspections and stuff. But we gathered that this is a February 1973 Minimoog. So it's early 73 Minimoog, which is right for the badges and everything. Also delaminated this badge, so it's nice and dark as well. And of course, it just looks fantastic. Everything looks really good. Sounds good. I'm very happy with it. And of course, you can see this side here looks great as well. There's the two holes I plugged right there. You can just kind of see these little dimples, but we didn't really want to replace this interface panel because that's the rare interface panel. It's got the embossed leather with a metal back, so it just, it's an era correct interface panel for 73. Once again, 72 would have been a smooth textured interface with a metal back, which is also very rare. It's actually probably a little bit more rare than this. But, this is a short run interface panels, just the same. But, anyways, let me get the camera on the tripod here, and I'll make you guys a demo. So anyways, I'll start off here with just a good sound for you, and then we'll break it down, go through oscillators, filter, envelopes, etc. here, like I always do. But here's just a good Minimoog sound. So anyways, you can hear how great this thing sounds. It's just got a really good sound to it. All the oscillators are working fantastic against each other. I will open the filter up, and we'll just start with oscillator 1 only, and get these all set up where they're even. So we'll go here. I'll go through the waveforms, the footages, as well as the detunes of oscillators, the volume, cleaned all the pots and rotary switches and everything. So you see how great this thing sounds. I get this thing where it'll sustain for me. And here we go. So here's oscillator 1 only. Good clean volume pot, as well as good clean switch. I'll also show you here, while we're in oscillator 1, I'll show you that the dead zone for pitch works. So I added the dead zone mod, so the pitch wheel is now going to have a true dead center of 0 volts when you return it to the detent. So you can see I can wiggle it within that detent and we have no tuning drift. Works very great. It makes this wheel so much more usable. So we'll go back here. So that's oscillator 1. Here's oscillator 2. Once again, all that's clean. I'll come back and show you the detune once I show you oscillator 3. So here's oscillator 3. Good clean volume pot here as well. And good clean mute switch. So now what we'll do, we'll go here and I'll show you that the oscillator 2 frequency works really well. Before I do that, I want to just show you how well the interaction is of these oscillators. So we'll turn all 3 oscillators back on. Oscillator 3 is out just a hair. Turn glide off. There we go. There's all 3 oscillators on. You know how great those oscillators work against each other. Just want to show you that real quick. I'll show you now that the actual detune works for oscillator 2. So here we go. There's oscillator 1 and 2 together just to retune it. Here's oscillator 3 detune. So anyways, there's all of our oscillators together there, and you can just see how great those things sound. Also, our noise source works great. Turn the oscillators off here. Good clean volume pot here as well. There's our noise source. Now we'll go to the filter. So I'm going to turn tracking off first. We'll just get this thing in self-oscillation. Start self-oscillating at the right point at 7.5. But right there is where it starts oscillating. So now we have no key tracking on. So here's key tracking 1 only switch. Turn that one off. Here's tracking 2 only. So you can hear, put them both together. we get full tracking. Put our 440 Hertz on, let me tune this thing up. Now the filter is never perfect on these early Minimoogs because the only way to calibrate it is with the back cover off. So when you put the back cover on, of course, temperature changes inside the unit makes it fluctuate a little bit. In 74 they changed that to a rheostat back there, and you had actually access to the outside of the unit. These early units don't have that. It was actually just a version 1 filter, and they just stuck a trim pod in there so you could actually scale it. So it's kind of just a modification they added. Got a little beating at the low end, but combine that back with the oscillators. Anyways, there's the filter. Something I always like to do with the filter is just put a little effect on it. So anyway, you can hear the filter. Filter works great. I sets it with tracking. Of course, once again, turn tracking off. Set that fixed frequency. While we're in the filter, though, I will show you the loudness control, or the filter contour. So we'll set everything to 0 in it. So it'll be just a click. I'll bring up our amount of a contour. You can hear we got just a click. Bring it down just a hair. We'll start with the attack. So we'll bring attack up slowly. So there's our attack, bring it back down to 0, excuse me. Then I'll bring up the decay. So here's our decay. As you hear, we're about at 2 on the setting here, so I won't go full because it's got a very long decay time, but we'll start backing that off. Downwards just a click. And then we got our sustain level, which sets the 0 point of our decay. We'll turn our switch over here for decay on. You can actually tune it with this, and you can have like this cool little and all you're hearing there is just a filter. That's all just a filter there. But that's your sustain level. Of course, you can go up higher than that. There it is at max. And like I said, if you put a little decay on it, you can actually set where you want the 0 point to be. There's 0. it with some decay time on it. But that's the envelope for the filter. So with the filter now the way, I will show you modulation real quick while we're in the filter section. So go here and turn oscillator 2 into, oscillator 3 into LFO source. No tracking. We engage that into the filter. Now when I bring up this wheel, we can actually modulate the filter. Or noise right now. But basically, you're hearing me modulate the filter by oscillator 3, which is now LFO source, or by noise. That's red noise and white. We can go here and turn that back into LFO source. Oscillator. Now we got the talking Minimoog. What sounds fun to do with these early Minimoogs is actually detune oscillator 3 a little bit. I'm going to show you the modulation real quick. Go here. You can actually hear the waveform inside that filter as it phases through the oscillators. Anyway, just kind of a cool sound there using the modulation effect there, detuning oscillators a little bit, and you can hear the phasing of the oscillators, which is something really cool about the Minimoog's filter and LFM kind of stuff there. So that's the filter. So open the filter back up, we'll go back to the oscillators. Let me retune that where I knocked it out a little bit while ago. So we'll get a sound set up here. And now I'll show you the loudness controller. So set everything to 0 in the loudness, so it's going to be just a click, as you can hear. So we'll bring up the attack. So there's our attack. Bring that back down. Here's our decay. then there's our actual decay. Then we've got sustain. So once again, just like the filter, it's going to set the 0 point of our decay. As you get some percussive. Turn that to 0. It's going to float that decay all the way back to 0. So anyways, that's our loudness control there. And I will show you now our modulation section again, our oscillator section. This thing set where it'll sustain. We also do have this decay switch over here I always mention as well. So basically it works as a, just like if you hold in a note, it's going to follow the decay. As you see. I have to hold in a note to hear the whole decay. When you hit the switch, it follows out the decay just as if I was holding a key. Like so. So as you can hear, that works great. So now let me go back here. We'll get this thing set up for a long sustain for me. And I'll show you the modulation into the oscillators. So use oscillator 1 only here. Turn oscillator 3 into LFO source again. Bring in our modulation switch. Basically, you're changing away from your LFO because it's oscillator 3. We can also put key tracking back on. Right now it's holding just a fixed frequency. We put this back on. All I do here is put a lot of glide on it. And they are injecting the oscillator back into the other two oscillators as an actual audio source oscillator. Just a little fun sound there for you. Also try and get this train out of the background. We can also inject noise into the oscillators. This is probably one of my favorite things to do with noise. It makes your oscillators kind of have a shutter effect. Let me retune this thing real quick because I've knocked everything out playing with this phase interaction. There we go. So now we'll bring this thing back down here a little bit. Usually I like to set about 8 o'clock or 8 footage. And now what I'll do, I'll bring up this wheel with noise. You actually make sure oscillators have this kind of wavering effect. But it sounds really good when you put a little effect on it. I'll get a sound kind of set up here real quick. Just a nice slow attack. And there it is, mixed with a little bit of the LFO3. You can actually use this modulation mix to mix the noise with the LFO. So you can kind of hear that sounds. So anyways, you can hear this thing sounds fantastic. But I just want to take a minute here and give you a quick demo, William. And once again, I really do appreciate you giving me the opportunity to restore this for you, as well as the Minimoog. And I appreciate all you guys that watch my videos. Couldn't do this stuff without you guys. So one other thing I did forget to show you real quick is I want to go down the scale of the keyboard, show you how all the keys work. So we'll go oscillator 1 only. Let me get this thing set back up. That word will sustain for me. So first I'll just show you that all the keys actually work. Then I'll hold this upper note and go down the scale of the keyboard, and you'll hear how great the contacts are mating against the actual buses. So here we go. Here's oscillator 1 only. You can hear. Now when I hold this upper key, I'm going to go down the scale, and you'll hear that all the keys actually fall in place. Try and glide off. There we go. as you can hear, all keys are working fantastic. But anyways, thanks again, guys. There'll be more to come here very soon. Take care.